So from here, the first question starts to ask us, what is the complementary and supplementary angles to 4 pi over 11? So complementary, what are we talking about there? 90 degrees. So when you're dealing with complementary angles, you're taking 90 minus your angle, or in our case, since it's in radians, it's pi over 2 minus your angle. So in our case, pi over 2 minus the 4 pi over 11. And basically all this is fraction work. So you got your calculator, use that alpha y equals key, because really all we're subtracting right here are what two fractions? So what's the first fraction?
First fraction is 11 pi over 22.
No. Well, yeah, because you made a common denominator. You don't have to make the common denominator for this. Your calculator doesn't have the alpha. Well, no worries. Well, your first fraction really is 1/2, which, yes, will be the, you said 11 over 22 minus 4 over 11. That's really what's going on, and then all we're going to do is just keep pi in the numerator. So when you subtract those two, what do you get? They do, which is why you said the 11 over 22. So you got the 11 over 22 minus 8 over 22. So 3 over 22. There you go. So there's a complementary angle. But again, you don't have to show all this work right here of getting that common denominator or anything like that. Let that calculator, let the big dog eat. Okay? And you can do it in your head too, absolutely. And then supplementary. So what are we talking about with supplementary? 180, absolutely. So that would be pi. So if it was in degrees, 180 minus it. But this time, because we're in radians, we're taking pi minus that. So we have pi minus 4 pi over 11. So in this case, what two numbers are we really subtracting? So in other words, the 1 minus 4 over 11, you converted it to the common denominator, which would be the 11 over 11 minus 4 over 11. So what does our answer get us? 7 over 11. And the pi still in top. Okay? All right, question number 2 says, sketch the angle A equal to negative 60 degrees in standard position and draw an arrow representing the correct amount of rotation. And then we want the least positive coterminal angle, the greatest negative coterminal angle, and the quadrant of the terminal side of A. So in order to sketch the standard position, where does the initial side have to be located? On the x-axis. There's our initial side. Then where does the terminal side now go? Clockwise 60 degrees. So I'm just guesstimating this, and that's what they're looking for. And on this one, if I remember correctly, on your test, it'll be a multiple choice. They'll have like a couple of pictures, and you will pick the one that is correct. So that's the picture that you're looking for. That is a standard position, negative 60 degree angle. All right, so now it says, give me the least positive coterminal angle. How do we get to those? Say it again. How'd you get 300? There you go. Take negative 60, and you just keep adding 360 degrees until you're between 0 and 360. So 300 is perfect. Now, this is the next question that I talked to you about in class. I said the word greatest right here, they have oops, messed this question up. Because to be the greatest negative coterminal angle, you need to be between 0 and negative 360. So what is the greatest negative coterminal angle? Yeah. This is the greatest negative coterminal angle that we have right now. But on this review, what the computer said, and when your guys' computer, and I'm going to go in and make sure that this gets fixed, they would actually make you subtract 360 from that, which is in fact not the greatest negative coterminal angle. So if you actually put in, what would that be, negative 420 degrees, that's what the computer would want, but that is not the answer. We want the negative 60 degrees because that is, in fact, the greatest negative coterminal angle. So I'm going to make sure that we check on that before you guys take it. But remember, the greatest negative coterminal angle is the number that's between 0 and negative 360. And then last but not least, what quadrant is the terminal side in? Quadrant 4. And I believe, again, this is one of those multiple choice questions where you fill in your dot. Okay? So basically, the least positive coterminal angle, all you're doing is taking your angle and you're always going to add however many 360s it takes to be between 0 and 360. Or in other words, keep adding 2 pi if you're in radians. To be the greatest negative, you'll take your angle and you will subtract however many 360 degrees you need to do to be between 0 and negative 360. Or in other words, 2 pi if you're trying to get the radian version. All right, question 3. All we got to do is convert this into degrees. 150 degrees is correct. So we take 5 pi over 6, and we're going to multiply it by what? You got it. 180, and in fact, it's over pi, because that's what's going to cancel out the radian type version of it. And then you'll get exactly what you just said, V, which is multiply the 5 and the 180, and then divide it by the 6, because in the end, the pi's cancel. And then all we do with fractions is multiply across the top, across the bottom, and you do, in fact, get 150 degrees in the end. Perfect. Nice work. Question 4. So this is the one, like I said, I had to look this up. It's a small formula. What is the formula for arc length? Yeah. S equals R theta. And what's special about theta? Has to be in radians. This guy right there is in radians. If it is not given to you in radians, then you need to convert it, which for us, it is not given in radians. So how do I convert 135 degrees to radians? So, and that's no worries if you've forgotten. Take that same fraction we just talked about a second ago and flip it. Yeah. So if you want to convert this to radians, slap 180 degrees on the bottom and put the pi on top and multiply. So when you reduce your fraction 135 over 180, you should end up with 3 pi over 4. Because the 135 over the 180 reduces to 3/4. So there's our radians. We know our radius. All we got to do is plug in and kick out an answer. So S equals 16.47 times 3 pi over 4. And then this one, the directions will tell you to round to 2 decimal places. 38.81 is in fact the answer. Cool. All right. moving on. So everything that we've just done, that was all a part of 9.1. So now we're jumping into 9.2. And your test will basically go in order of each one of those sections too. So it's not like I'm going to mix and match the questions throughout. I'm not going to mix them up. We're going to go in order. So here you see an angle that is in standard position. And you have the point, which they give us up here in the problem, of 5 over 13, comma 12 over 13. And it wants you to tell me the following functions: sine, cosine, and tangent. Remember, because we are on the unit circle, that means that we don't have to worry about the radius, because the radius is just 1. So what is the formula for sine when given a point? That's right. It's just the y value. So the y value was the 12 over 13. Perfect. What is the formula for cosine? Right on. The x value, 5 over 13, is spot on. And then, now we're going to talk about the tangent. What's y over x? So I like that you called it 12 over 5. If we actually look at the math behind it, you really do have 12 over 13 divided by 5 over 13, but remember, we don't really divide fractions. We do that keep, change, flip. Oops, not 13, or 12 down there. Let's actually put the 13. Change the division to multiplication, flip the bottom guy. And when you cross off those guys, it leaves you the 12 over the 5, which you came up with. Perfect. Right on, right on, right on. So again, we're on that unit circle. So that makes things a whole heck of a lot easier for us. So that means our R is 1. And then they wanted you to go around 4 pi. Okay, this is where if we use those least positive coterminal angles, it's going to relate to one of these 4 guys up here. One of our least positive coterminal angles will relate to that. So 4 pi, let's get its least positive coterminal. What do we got to do? Keep subtracting by 2 pi. So if I subtract it once, I get 2 pi. And then I'm good. Because 2 pi is this point that's right here. Which is also 0 if you subtracted it one more time. Okay? So now you know that you're working with that point right there. And all we got to do is just get our trig functions. So again, what was the value for sine? It was y, which is 0. What about cosine? It's 1 because that was the x value. And tangent? It is 0 because you put the y over the x, which is 0 over 1, and they do want you to reduce that down. What about cotangent? Undefined, exactly, because remember, cotangent is just the reciprocal of tangent. So, yeah, you get 0 in the denominator, which we cannot do, so that's undefined for us. And secant? It would just be 1 because it is the reciprocal of cosine, which puts it as 1 over 1, which is just 1. And then last but not least, cosecant is undefined because that's the reciprocal of sine, which puts 1 over 0, which is undefined. Perfect.
Before, I used to get confused of which secant and cosecant goes to, and then I just figured out that secant starts with an S, so it's the opposite of sine, so it'll be cosine. And cosecant, I just it's reciprocal of sine. I just get the letter.
Yeah, I mean, kind of the cool things is if you're trying to, if you get these guys messed up right here, secant, cosecant, sine, and cosine, I like what you said about the letters. Sine is actually going to match up with cosecant. And secant will match up with cosine. How I think about it is just like what you said, the opposite letters. Sine and secant will never come together because both of them start with X. Cosine and cosecant will never come together because they both start with C. They always have to have the opposite letter for it. So sine goes with cosecant, and secant goes with cosine. Or another way I think about it is the two cos will never go together. Cosine and cosecant never go. They don't like each other. All right, so the next guy says, given angle theta with sine alpha equal to negative 15 over 17 and cosine alpha equal to 8 over 17, they want us to find the following trig functions. So again, we're still in 9.2 in here, so that means we're still dealing with the unit circle. So when we start thinking about who's positive and who's negative, we don't really have to worry about that in this, because remember that sign always represents which variable, since we are still on the unit circle.
The thing that you guys talk about, I don't know that. I just do it by the values here.
Okay, so he just takes the values. Well, just remember that sine always represents y, right? Cosine always represents the x. So all you got to do is just apply the formulas to them. There you go. So, oh, okay. So what he's asking about is he's asking about the all students take calculus. So that, no, I was talking about how we know that we don't have to worry about a radius on this and just how we can go about getting the answers. So he was talking about the all students take calculus, the ASTC, which is all about the signs of your trig functions. We'll talk about that soon enough. We didn't hit that in this section yet. So tangent alpha, well, that would be, as we talked earlier, our y over the x. So we just take our y value, which is the negative 15 over 17, divide that by our x value, which is 8 over 17. And again, you've seen this before. We're just going to do that keep, change, flip. So we'll keep the first fraction. We'll multiply it by the reciprocal of the bottom guy. So that gives us the negative 15 over 8. And then now that we know these guys, the rest of them are pretty easy because they'll just be reciprocals of them, like what we talked about a moment ago. So what is negative 17 over 15? Because cosecant is the reciprocal of sine. And secant is the reciprocal of who? So the reciprocal of cosine, which would be 17 over 8, about 0.5. And then cotangent would be the reciprocal of tangent, which we just found. Negative 8 over 15. We're not worried about who has the negative in this one. That's not important for us. So, moving on to question number 8. So, question number 8. Now we're going to jump into those graphing sections right in the middle. So now we're in 9.3. Okay? So now we are jumping into section 9.3. So remember, when you're looking at these guys, whatever your trig function is, remember that, let me fix that equal sign, that's horrible. Remember that C plus A, and then whatever your trig is here, or if I could spell right today, whatever your trig function goes after the A. Oh, let's get an actual pen. And then it's B parenthesis X minus D. So this is what we're dealing with over the next couple questions with our graphing. So here it wants to know the amplitude. And the amplitude dealt with which variable up there? It's 4. Yes, you got the number, which deals with the A. The A was all about amplitude. And in our case, this time it's 4. And then next, it wants us to find the period. Well, since we're dealing with sine, remember that sine and cosine have a period of 2 pi. But when we actually have a b value, we run a little formula where we take 2 pi divided by b. Well, what is our b in this case? 6. But you also have to remember in here, this guy right here should look just like this piece over here. So I said in class to do what? There you go. So we got to pull this 6 out right here in front of the x as a GCF, and that changes everything else below it. So if I pull a 6 out of the 2, what does that give me? 2 over 6, which reduces to 1 over 3. So this is really what we're looking at inside the parenthesis over there. So I agree with you that b is 6. And so when we actually plug into our formula, you end up getting the 1 over 3, which is pi over 3. So that is our period now, pi over 3. And then it asks, what's the phase shift? And then that's where we go for the value of d. So our period was all about the b, and then absolutely right with the last piece, the d is all about the phase shift. So the d would be 1 over 3. And again, this guy would be a multiple choice question, so you just figure out which one has all 3 of those answers. All right. So now we actually want to graph. Now remember on this one, because we are working on the computer, this one will have a box that pops up for you to help you manipulate. So if you know what the amplitude is, the period, the phase shift, if there's any reflections and things like that, the box will do all that stuff for you. Although this time we'll do it by hand. This is not too complicated of a problem either. So what is our A? What is our amplitude? Our amplitude is 1 because that's the number in front of our trig function, which is 1. So that means the highest we'll go is 1. The lowest we will go is -1. I'm going to go ahead and kind of mark that up here. So the highest I'll go is 1. The lowest I'll go is -1. Okay? And then from there, we get our period. So what is our b value? 1 over 4. So we're going to take 2 pi divided by 1 over 4, and it makes it. There you go, 8 pi, because you end up flipping the 1/4, which becomes 4, and 2 pi times 4 is 8 pi. So the longest we will go up here is to 8 pi. So I'm going to call this guy right there 8 pi. So then now we can start thinking about, so he always skips all this, but I got to talk about it real quick just in case some people don't skip all this. So, I mean, yeah, from here you can kind of think about what's going on. But I'm going to go ahead and put up the midpoint and then the other 2 midpoints. So from here, to get the midpoint, well, what's halfway between 0 and 8 pi? 4 pi. And then what's halfway between 0 and 4 pi? 2 pi. What's halfway between 4 pi and 8 pi? 6 pi. So now you just got to remember what happens on your graph. Sine, does it start at 1 or does it start at 0? Starts at 0. And then where does sine go? It goes up. Then where? Then it goes back down. Then where? Then it goes to the -1, down further, and then back up to the 8. So once you plug in that information that we had over here, the amplitude, the period, there's no phase shift, because I believe it'll ask you about that. The phase shift would be 0. And then the other guy, vertical translation. Would be 0. So these are like the 4 numbers that you'd have to put in that little box when you guys were doing this on the computers. So you put all that in, and it generates that graph that we just saw right there.
Because you always have 4 different graphs. So with them, they always have the opposite amplitude, so it would be a negative value.
Mm-hmm.
Because you see how you said sine goes up in the beginning?
Yep.
You would have sine going down, so that's already 2 off. And then from the 2 graphs that you have left over, there's always only one that has the correct amplitude. That's why I only skip it.
Yeah, and this one, it is a multiple choice question, so you could use, some of that process of elimination to look at things. If you know that your graph does not reflect, that took out, half of the graphs you said? So then you end up with a 50-50 shot, and then you just kind of got to look at the period and the amplitude and make sure that they match up with what we're talking about. So yeah, there are lots of great ways to problem solve this without fully knowing how to graph, but this is really the full graphing kind of a experience.
They were really similar, then I'd be screwed because I would have to work it out. And if I always do it the fast way, then I wouldn't know how to work it out.
Yeah. So, all right. Jumping to the next graphing. So we're still in 9.3 because we're talking sine and cosine and all that. So again, we got to graph this guy. So let's just start going through some things. What's the amplitude? Amplitude is 4. So that means the highest we're going to go is 4. So call that 4, just counting by ones. And we'll slide down some. -1, -2, -3, -4. Okay, so there's our amplitude. So the highest we'll go is 4. The lowest we'll go is -4. I know it says 2 periods up here, but I'm only going to do 1 because it's just silly to do 2 periods. What's the period? The period is still 2 pi. It doesn't change because your b is 1. Is there a phase shift? Yes. What is the phase shift? -pi/2, because you got to give me the opposite of what's going on in here, because the original formula has the subtraction. So we're shifting everybody -pi/2. In other words, we're going to the left, pi/2 with everybody. And then, is there any vertical translation? I don't know why I put 2 T's. Translation would be a 0 in that guy. Okay? Now, this one we actually have to graph out, right? All right. So in this one, this is where we got to start thinking about, okay, we can go in, and the other day I showed you, well, not the other day, your classmate showed you that the original period for this guy was here. Sorry, I didn't mean to just put pi. Come on, you. But remember in class I showed you that we can take this and we can solve it with what we were dealing with by subtracting the 2 pi to all sides. Or sorry, not the 2 pi, pi/2. And that gives you -pi/2. So that's where our graph was going to start. I don't know why some of my pi/2s are disappearing. Uh-oh. One notebook has stopped working. Hang on a moment. One notebook is restarting. So give me just a second. We'll get back up and running. What? You want me to continue talking? Oh, yeah. There we go. So now we're back down here. It's just a little bit back work to throw back up here real quick. So we're subtracting that pi over 2. That gives me pi over 2. Stop it. Whatever. So negative pi over 2 less than or equal to, my pi's over 2 are disappearing. This is so weird. And then over here you'll end up with 3 pi over 2. Let's see if it'll come back. Maybe. There it is. Don't touch that. So now we know where we begin, and now we know where we end. And the cool thing is, working with pi over 2 is nice on our graph. Doesn't make things overly complicated. So I'm just going to count by pi's over 2 up here, which makes things a heck of a lot easier. So there's negative pi over 2. So we know that's where our graph begins. We got positive pi over 2. We got pi, and we got 3 pi over 2. So that really represents all of our midpoints that we need. And now we just need to draw in the graph of a cosine. So pi over 2 is quite nice to us. So if we look at this, where does cosine start? Up at the top at 1 or down at the bottom? Or, excuse me, at 0? Yeah, it would actually start at 4, which originally would have been the 1. So our graph starts up here. At 4, then where does it go? Then it goes to 0. Then where does it go? Down to the negative 4. Then where? Back at the x-axis. Perfect. And so here's our graph. Whee! And back up. And there. Now again, I only drew one period, but it wouldn't be too hard to continue. But the other thing is, also just remember this, on the test you're putting these values in that little box and it will generate the graph for you anyway. So it's not like you actually have to do this physically by hand. All right. Jumping over to question number 11. So now we jump into 9-4. Now we are jumping into 9-4. So this is where we have the cosecant, the secant, the tangent, and the cotangent graphs. Make sure that you're really, really careful on these questions because this is where your periods change, and it also changes where it likes to start and end. Things like that. So the other cool thing is these are all multiple choice questions, so you can also kind of use some of that logic to help you out. So up here, what is our amplitude? -5. Well, be careful. Amplitude is always going to be positive for us, so it'll be 5. But what does that negative do then? Yes. Because this guy is negative, that means we're going to reflect over the x-axis. So keep that in mind when you're kind of looking at your pictures. If it's not a reflection, then you get to throw that guy out. So cosecant, who is that graph based off of? It's based off the sine. So if you know what sine looks like, remember I talked about that in class. If you know what the sine graph looks like, then basically all you do is draw parabolas at the top of your hill and at the bottom of a hill. So just a couple other things. Has our period changed? Nope. Period's still 2 pi. Is there a phase shift? Nope. Is there a vertical translation? So there's no phase shift. I'm going to kind of abbreviate that. PS for phase shift. Vertical translation is 0. So all we basically got to do is just draw a sine graph that has an amplitude of 5, and then draw parabolas at the top and the bottom of its hills, wherever they're at. Everything else still stays the same. So here's my 2 pi, here's my 3 pi over 2, here's my pi, here is my pi over 2. Okay? And then let's just say, because I don't want to really count it out, that's 5, and this guy is -5. So a sine graph starts where? Up at the 5 or at 0? Okay, it starts at 0. Now, because we are reflecting, this is where we got to keep this into consideration. Where do we go from here? Do we go up or do we go down? We go down, because the original sine graph will start going up in the beginning. But here we need to go down. Then where? Then it goes back up, and then where? Then the 5, and then back to the x-axis. Now, because this is cosecant, anywhere you hit the x-axis, those are vertical asymptotes. Anywhere where you hit the x-axis, those are your vertical asymptotes, because that's where we are undefined. So these are all your vertical asymptotes. And then at each one of those points that are between there, that's where you draw your parabolas. So this guy is facing down. This guy is facing up. Okay? And so all you have to do is find a picture that looks just like that one. All right. Jumping over to number 12. So again, be careful with cotangent. Be careful with cotangent. It's one of the tricky ones between tangent and cotangent. Tangent starts at -pi/2 and goes to a +pi/2. Cotangent starts at 0 and goes to pi. So be very, very careful and make sure that you know where these periods start for these two functions. Tangent starts at -pi/2 and goes to pi/2. Cotangent starts at 0 and goes to pi. So keep that in mind. All right, so now looking up here. What is our amplitude? Our amplitude is just 1. But because it's negative, what does that tell us again? Reflect over the x-axis. So in other words, our cotangent graph is actually going to kind of turn into a tangent graph because of the reflection. So from there, do we have a period change? No. Period is still pi. It's a horrible pi. Do we have any phase shifts? Nope. Phase shift. Do I have a vertical translation? Yes. Where are we going? We're going up 2. So, since my period doesn't change, this guy right here, that's pi. Right in between will be pi/2. This guy right here will be 3 pi/4. This guy will be pi/4. And now we can start working everything. Remember with cotangents, your beginning and ends are asymptotes. Same thing with tangent. The beginning and the end are asymptotes. And your graph exists between these two. Now comes the information. So I'm just counting by ones. That's good enough. Cotangent originally starts where? Does it start at 1 0, or negative 1? It originally starts at 1. But because we are reflecting, where would it start then? At negative 1. And because we have a vertical translation, we move up 2 from negative 1. Does that make sense? So it'd be, no, from negative 1. Yeah, it'd be 1. At the middle, the pi over 2, usually that's 0. But because we are moving up 2, where do we go? Ooh, stuff popped up. We go up to 2. And then 3 pi over 4, usually it is down at negative 1. But now, because we flipped it, it was at 1, and we had to move it up 2, so it's right there. Now, I know this looks like a diagonal line, but remember, these graphs look like the cubic graph. So you just got to make it a little bit curvy. So you come up and curve and up. So that's the picture you're looking for. Okay, jumping out of graphs now. Now we are jumping into 9.5. This is where we are no longer on the unit circle. So this is where we have to care about our radius. So 9.5, we're caring about our radius. So the first thing is it wants us to sketch the angle in standard position. So again, where does the initial side of standard position start? X-axis. And let's say I'm counting by 4s, just to make things easier. Where does the terminal side of this go then? Yeah, it'd be at pi, right here, because this guy is my negative 8, 0, right? And so this guy rotated that direction. So that would be the picture you're looking for. And now, since you already know what's going on, this guy's going to be like pi. Okay? So, real quick for this, to find sines, cosines, and tangents, because we are not at the unit circle, our radius is not 1, we should find the radius. What's the formula for finding the radius? X squared plus y squared. It's your Pythagorean theorem. It's basically your Pythagorean theorem. So we plug in, we get negative 8 squared plus 0 squared. So negative 8 squared is 64 plus your 0, which just gives you, oops, square root of 64. I jumped straight to the answer. My bad. Which gives us 8. Okay? Remember what I told you in class? That your radius is always positive. Your radius should never, ever be negative. So keep that in mind when we start going through the rest of these questions. So now when we come over here to do our sine, cosine, tangents, cosecant, secant, and cotangent, this is where we're going to go back to those formulas that we had in 9.2. But now, instead of the denominator not existing for us because the radius was 1, the radius will actually come into play for us. So when we look at sine, what was the original formula for sine? Y over R. So this is where the R comes into play. So if I put my Y value, 0, over my R value, which is 8, that gives me 0. Cosine, what is the equation for it, or the fraction for it? X over R, which will be negative 8 over 8, which gives us negative 1. Tangent is what over what? Y over x. That's still the same. So we put 0 over negative 8 and gives us 0. Cosecant, who's that just like? It's like sine, but it's the reciprocal. So that's the r over the y. So you put 8 over 0, which gives us undefined. Secant is just like who? Like cosine, but it's the reciprocal. So secant is your r over x, which is 8 over negative 8, perfect, which is negative 1. And then finally, cotangent is the reciprocal of tangent. So that gives us negative 8 over 0, which is undefined. Again, knowing that this was at pi, it runs the same information as pi. So all these, if you were looking at your chart, are the same answers that are from your chart at pi. That's what's really cool about it. Okay. So now, again, we're still in this section where r is important to us because we're not on the unit circle. So they've given us two pieces of information. They've given us negative 8 over 15. And remember, how was tangent made? Sine over cosine, or in other words, y over x. So we know up there our numbers for y and x are 8 and 15. But the other piece that comes into play is this guy right here. What do we know about points in quadrant 4? Yeah, you do. Promise you know stuff. We know that x has to be positive and the y has to be negative. And that's where you'll figure out where the negative belongs in your fraction. Nope. No need for all students to do calculus yet. Just yet. We'll talk about, but this will come into play on this one too. So now, with what we know up here, we know that we have negative 8/15. Who is really the negative value? The 8, because that's our y value. And the x is really a positive 15. So now we know the point. The one thing that we're missing is the r. So what was our formula for r? There we go. So we just plug in real quick. 15 squared plus negative 8 squared. So that would end up giving us 225 plus 64, which gives us the square root of 289, which is 17. So now we know r, now we know x and y's. We can actually go in and write our trig functions. So we remember sine from the previous problem is what variable over what variable? Y over r. So all we got to do is plug in our y and plug in our r. What is our y? Negative 8. And our r was 17. Let's go ahead and write this up here. I don't know why this board's being wonky right now. So negative 8 over 17. All right, cosine was what over what? Yep, because it's your x over the r. So that's 15 over 17. Tangent is what over what? 8 over negative 15, because they actually gave us that one. Cosecant is what? (17 over negative 8), because it's the reciprocal. Very good. Secant? 17 over 15. Right on. And cotangent? There you go. 15 over negative 8. Or you could put the negative on top. It really didn't matter. So let me go back and adjust these. I know some of you are probably freaking out. He messed it up. Because the 8 was really the negative guy. So there you go. All good. All right. So now we are jumping into 9.6. SOHCAHTOA. So now we're jumping into 9.6. SOHCAHTOA. Remember, everything with SOHCAHTOA is based off of where your angle's at. So who is the 16? That is the adjacent. Who is the 63? Opposite. Very good. And that leaves the last guy, the hypotenuse. So all we got to do now is just write our trig functions. So sine is who over who? 63 over 65, which is very good because remember sine is the opposite over the hypotenuse. Cosine, who is that? 16 over 65. Because that's the adjacent over the hypotenuse. Tangent is who over who? 63 over 16 is absolutely correct because you've got the opposite over the adjacent. Okay? And then now the other guys is just like what we've been talking about. These are all those reciprocals. So who's the reciprocal for cosecant? 65 over 63. Who is the reciprocal for secant? 65 over 16. And who is the reciprocal for cotangent? 16 over 63. Perfect. There you go. All right, number 16. So find the exact value for this guy. Tangent 3 pi over 4. Now remember on your test I said I'm going to be giving you only the first quadrant. Only the first quadrant. So this is where in 9.6 we talked about reference angles. So we're going to be talking about a lot of reference angles here. So 3 pi over 4. And here's how you start thinking about reference angles. Okay? In here, oops. Come here, you. In quadrant 1, this is how I remember it from my mind. You need your fraction to be between 0 and 0.5. If your fraction is between 0 and 0.5, you're in quadrant 1. Quadrant 2, your fraction needs to be between 1 and 0.5. If you're in quadrant 3, your fraction is between 0.5. Go away. 0.5 and 1. And if you're in quadrant 4, your fraction is between 1.5 and 2. So if you look at 3/4, that's 0.75. So I know that this angle lies in quadrant 2. Follow me on that? So that means in order to find this reference angle, remember I gave you this chart in class that if you're in quadrant 1, that is the reference angle. And now it's writing in Egyptian. And now I'm just coloring it in even more. Come here, you. That way, if you are in quadrant 1, that is the reference angle. If you're in quadrant 2, you need to take pi minus the angle. If you're in quadrant 3, you'll take the angle minus pi. And if you're in quadrant 4, you need to take 2 pi minus the angle. That was the chart that I gave you in class that helped you figure out reference angles. So since I'm in quadrant 2, I'm going to be taking my angle, and we're going to take pi minus it. So what is pi minus 3 pi over 4? Pi over 4. So this piece of information is the same answer as tangent of pi over 4. Well, what is tangent of pi over 4? And this will be something that you'll see on the board. You'll see it's 1. Now, this is where I also talk about the all students take calculus. All students take calculus. The A stands for quadrant 1. And it's the word all, because everybody in quadrant 1 is positive. The S is for when we're in quadrant 2. And the S is for the sine function and its reciprocal, which would be cosecant. That means in quadrant 2, sine and cosecant are the only positive ones. The T is for quadrant 3. And the T means that tangent and its reciprocal, cotangent, are the only ones that are positive. And then the C is for quadrant 4, meaning that cosine and its reciprocal, secant, are the only ones that are positive. So this is the last thing you have to consider with this answer. So 3 pi over 4 is in quadrant 2. And in quadrant 2, sine and cosecant are the only ones that's positive. So what does that tell you about the tangent answer then? That it has to be negative. And that's the answer. Come here, you. Start writing.
What's stopping us from putting all this into the calculator?
What do you mean? From the beginning? Nothing. Because you could actually go into the calculator and actually plug this in and get it. Okay? But sometimes you're not always going to have that luxury where it comes out nice and neat. So, and it wants the exact answer. So you got to be careful. Got to be careful. Because not every answer is nice and neat in trig. All right. So let's take a look at another one. That's not the only problem where you actually do that at. So this guy says find the exact value for this one. So we're going to do this again. And if you go straight into your calculator, I believe this is not a nice, neat answer. It's going to come out as a decimal. So this is kind of going back to your situation. What's to stop me from using a calculator? This guy right here. Because it is not a nice answer. So first things first, let's find the reference angle. If I take 2 divided by 3, I get 0.66, repeating. And so that means I'm in quadrant 2. So to find the reference angle, we're going to take pi minus 2 pi over 3. I don't know why this thing is acting so weird. Fix this. And if I subtract those, I get pi over 3. So this function is going to be related to pi over 3. Well, on the board in class, you'll have the answer to this, which is 2 squared to 3 over 3. So now you just got to think about what's the sign. And that's that all students take calculus. So we're in quadrant 2. That means sine and its reciprocal cosecant are positive. So what's that tell you about the answer of cosecant 2 pi over 3? That it's got to be positive, right? So all we got to do is just rewrite our answer. Yep, because what I just talked about a moment ago. 2 pi over 3, if I take the 2 divided by 3, that's 0.6 repeating. That means I'm in quadrant 2, because in quadrant 2, you have to be between 1 and 0.5. All right, number 18. So it says write the cofunction, but that's pretty easy. Because remember, all you got to do is basically take 90 minus your angle and just know who the reciprocal of this guy was. So who's the reciprocal of tangent? Cotangent. And then all we got to do is take 90 minus 25. 90 minus 25. Nope.
I don't know why I can't do the simple math.
It's okay. You don't. You got a calculator. Take your time. It's not a race. There's nothing wrong with it. 65.
It was like a block in my head.
There you go. That's what they want. When you do the cofunction, you basically give me the reciprocal function, and then you take 90 minus the angle. Or if it's in radians, pi over 2 minus the angle. Okay? Getting near the end. So here, again, this is after the reference angle. So this is why I kind of taught you that trick. If you take 11 divided by 9, what do you get? Yeah, just use a calculator. Take 11 divided by 9. 1.2 repeating. So what quadrant does 1.2 repeating have to be in? Has to be in quadrant 3. So we know this guy is in quadrant 3. So that tells us what formula to use for the reference angle. So in quadrant 3, we're going to take 11 pi over 9 and subtract pi from it. That's the formula. You take your angle minus the pi. And so when we subtract that, what is our reference angle? Say it again. It's not pi over 3. So in other words, you're taking 11 over 9 minus 1. Two pi over 9. And that's all they want. That's it. Okay. Number 20. Number 20. So again, what's a reference angle? What's a reference angle? So first thing is, because this is negative, you got to get to the least positive coterminal angle. So what do I got to do with this negative pi over 6? Add 2 pi. So negative pi over 6 plus 2 pi gives us what? What is negative pi over 6 plus 2 pi? (13 pi over 6). 11 pi over 6. There we go. So, real quick, what quadrant is that in? If I take 11 divided by 6, what do I get? 1.83 repeating. So what quadrant must that be? Not quadrant 3. Has to be quadrant 4. Because quadrant 4, you are between 1.5 and 2. Quadrant 4, you're between 1.5 and 2. And you said this was 1.83 repeating? Yeah. So that means when we're in quadrant 2, all we're going to do is take 2 pi minus that angle. And what do you get? Uh-huh. One pi over 6 or pi over 6, all the same. There you go. And then you could also kind of use, I mean, if you look at this one, the answer is pretty much given to you from the very beginning. If you are going a negative pi over 6, that really is your reference angle because that's the smallest that you can be. All right. So, moving on to number 21. All right. So, again, this is one of those things where let's get the least positive coterminal angle, and then from there we can get all of our answers that we need. So, least positive coterminal angle. So that means I got to take this 1,110 degree angle and subtract off 360 degrees a couple different times. Say it again. I end up getting 30. How many times do you have to subtract 360? How many? 3 times? So you end up getting 30 degrees. So all of these guys are related to 30 degrees. All of these guys are related to 30 degrees. So if you know what sine of 30 degrees is, you know the first guy. You know what cosine of 30 degrees, you know the next guy. So again, this will just be all up on the board for you guys in class because I said I'd give you the quadrant. So sine of 30 degrees is a half. Cosine of 30 degrees is the square root of 3 over 2. And let me fix that too. Tangent of 30 degrees is the square root of 3 over 3. Cosecant of 30 degrees is 2. Secant of 30 degrees is 2 square roots of 3 over 3. And cotangent of 30 degrees is the square root of 3. And you do not have to worry about any signs because this angle is in quadrant 1. So everybody's positive.
But you know how if you sign up 30, if you sign up 1,110, you still get it.
Yes, absolutely, because they're all coterminal angles. So yes, if you take sine of 1,110, you do get a half.
Yeah, but the reason why you want to get 30 is because you only have quadrant 1.
Say it again.
The reason why you want to change it to 30 is because you're only giving us quadrant 1.
The reason why I have you change it to its least positive coterminal angles to know what quadrant you're in, so that helps you with the signs. And that would have told me which one to compare it to in quadrant 1, and then from there I would use the signs. But since our angle is 30 degrees, that is our reference angle, and so we just got to look at what happens at 30 degrees. All right, the next guy. So again, here's kind of the same idea that we just kind of talked about. We will want to look at this guy as a least positive coterminal angle. So this is kind of going back to what we were talking about a moment ago. They're giving us some weird angle. We need to get that least positive coterminal angle. And then from here, you're going to find out that we have to look at a reference angle to help us out with this guy. So what is the least positive coterminal angle with negative 5 pi over 4? So what are you thinking? What do you got to do? So he's working with 2 pi because we got to add 2 pi to that, right? So he's just making his fractions, doing some work, getting that common denominator. So he'll end up with negative 5 pi over 4 being added to 8 pi over 4. So 3 pi over 4 is our least positive coterminal angle, but that's not a quadrant 1. So now we talk about its reference angle. And 3 pi over 4, this is actually in quadrant 2. Because 0.75 is in a quadrant 2, because quadrant 2 is between 1 and 0.5. So to get the reference angle, all we're going to do is take pi. I don't know why I drew the angle symbol. We're going to take pi minus 3 pi over 4, which gets us pi over 4. So all these angles are going to be like pi over 4. And then we'll worry about the quadrant 2 part in the end to get the signs. So if you look at pi over 4, all of your answers will look like this. Sine being the square root of 2 over 2. Cosine being the square root of, silly board, square root of 2 over 2. Tangent being 1. Cotangent down here, come here you, scroll up, being 1. Cosecant ends up being the square root of 2, and secant being the square root of 2. Now you got to worry about the signs. So again, this is where we go back to all students take calculus. So we are in quadrant 2, so that's about the S. So who has to be positive? Sine and cosecant are positive. That means everybody else is negative. And there's your answers. All right, jumping to the next guy. This guy right here, calculator work. Calculator work. And it will want you to round to 8 decimal places. So you just go into your calculator and you can type this in. Or the other thing you can do is you can convert this minutes right here into the degrees and then type it in as 1 decimal number. Just to remember how we convert minutes into degrees, divide by 60. So that's 0.7. So if you want to just go into your calculator and work secant of 37.7 degrees, that will work. There is no secant button, so think about its reciprocal. So really what you're going to look and what you're going to run in your calculator is 1 divided by cosine 37.7. And again, make sure your calculator is in what mode? Degrees. So keep an eye out for that. So when we take 1 divided by cosine 37.7 and we round to 8 decimal places, what do we get?
6.38653.
Perfect. There it is. Your directions down at the bottom say round to 8 places. Follow those directions to a T. Yep, yep. All right. 2 more. So 24. So here we are now in section 9.7. So this is the last section that we talked about. So here, this is what, remember what I called destroy the right triangle. Figure out everything about it. So the angle's pretty easy to deal with. What are we going to do? Yeah, 90 minus the angle given to us. 90 minus 57.1, which gives us what? 32.9 degrees. And then everything else in here, we're going to use trig on. And the directions, if I remember right, they say round to the nearest integer. round to the nearest integer. So keep an eye on that. So if we want to, real quick, we know who our angle n is. So who does our capital N, I mean for that. So who does little n represent according to that angle? That's the opposite. Who is P according to the angle? Hypotenuse. And that means, last but not least, this guy down here has to be the adjacent. So if I want to solve for n, what trig function do I have to run? Perfect. Because it utilizes the opposite and the adjacent. So this is what we're looking at. So when we cross multiply to solve, n is equal to whatever 121 times tangent 57.1 is. And it says round to the nearest integer, so 187. Perfect. And then our next guy, what do we have to use to find the hypotenuse? Cosine, because that's what utilizes the adjacent and the hypotenuse. Equal to 121 over P. And then what did I tell you that you could do? Yeah, these two guys right here, there's a rule in proportions that says, hey, we could swap these two. Yep. So in the end, you take 121 divided by cosine 57.1. And so when you divide those and round to the nearest integer, what do you get? There you go. P equals 223. Last problem. Last problem. And this is one where I would draw a picture if I were you. And again, I'm not going to see your picture. Neither is the computer. No one's going to make fun of you if your picture looks weird. So right here it says you are headed towards a plateau, which is 48 meters high. If the angle of elevation to the top of the plateau is 10 degrees, how far are you from the base of the plateau? So here's my picture for this. Here I am, walking along. There's some sort of plateau up here that I'm headed towards. It says my angle of elevation is 10 degrees. Remember in class I said your angle of elevation, there's a horizontal line from your eyesight. And when you look up, that's your angle of elevation. And then they also told us one more thing. It says that we are headed to a plateau that is how tall? 48 meters. They want to know how far are we from the base. So they want this piece of information right there. So, according to everything I know here, who is the 48? And we're trying to find the adjacent, so what trig function is that? Tangent. So tangent 10 equals your opposite, which is 48, over your adjacent, which is x. And again, we just talked about this a moment ago. All you got to do is switch those around. And do your quick division. And this one wants you to round to 2 decimal places. Perfect. And that's it. That's what your test is going to look like. It's just going to be on computer. Over here.